Hello everyone, welcome back. Today we are going to talk about an important data structure called the stack data structure. If you guys are new, please consider subscribing for more such computer science videos. So let's get started and define a stack data structure. A stack data structure in computer science is a linear data structure like array and linked list, but a stack data structure follows a certain sequence, or it follows a certain rules when it comes to accessing, deleting, or adding items to the collection. In array data structure, we saw random access was possible. So say we have this array of numbers, the array name is A. If I wanted to access number 1, I could easily and directly access number 1 using its index value. If I say A of 2, this is going to give me number 1. Say I want to access number 4, I can access number 4 is using its index value. I can say A of 1 is going to give me number 4. Same case, we learned about another linear data structure called the linked list data structure. Only sequential access was possible in a linked list data structure. Say I want to access number 5, so I definitely have a head pointer to my linked list. Using this head pointer, I would start traversing over the linked list until I reach number 5. In linked list data structure, only sequential access or retrieval is possible, not random like array. But when it comes to a stack data structure, a stack data structure follows different rule. We can only add or remove or retrieve data from the top of the structure. In other words, items are retrieved only from one end of the structure. We cannot retrieve data from any given position in a stack data structures like we did in an array or a linked list data structure. A stack follows a rule called LIFO, or last in first out. The item inserted last in the stack data structure will be the item popped or removed first. We can also call it a FILO. Stack follows a FILO rule, or first in last out. The item inserted first in the collection or a stack will be the item popped or removed last from the stack. Imagine a stack of book. You can only take a book from the top, and when you add a book you can put at the top as well. Say this stack of book is inside a box where only one end of the box is open and other 3 sides are closed. So if I want to add a book, I can only add a book at the top of this stack of books. And if I wanted to access a book, the first book would be the topmost book I could access. I cannot access directly this pink book. If I wanted to access this pink book, I should first access and remove this topmost, then this book, then this book, then this book, and this book. Then only I can access the pink book. Same case, when I wanted to add a book, I cannot add a book at this position. Say I want to add a book at the top of this yellow book. I cannot do that. I can only add a book at the topmost location, which is top of the stack. Same case with the cane of tennis ball. Say this is inside this box, only one side is open, the other 3 sides of this box is closed, so only this top of the box is open. If I wanted to access a ball from this can, I can only access the topmost ball in the can. Same if I want to insert a new ball, so the new ball will be inserted at the topmost position of the stack. Same case with the plate of stacks. So when the plate is empty, so first I will insert plate number 1, number 2, number 3, number 4, number 5. So number 5 is inserted last. This number 5 will be the plate removed or accessed first from the stack. Same case with the stack of coins. Same as array and linked list data structure, a stack data structure is also used to store collection of same elements. So we can only store either integers, string, characters, floating points. So we cannot store mix of data types in a stack data structure. So in a nutshell, we can say that a stack data structure is a data structure for storing collection of elements, but with different properties and limited operation than array or a linked list data structure. So what operation basically we can perform on a stack data structure? The first operation is called the push operation. It basically adds an element to the top of the stack. When we want to add an element, the operation in a stack is called push. Say we have a stack here, and if I want to access add number 1, 2, 3, so first I will add number 1. So one will be added in my stack. So right now the top of the stack is 1, since I have only one item in my stack. Then if I want to push or add number 2, So number 2 will be pushed on the stack, and number 2 will be the top of the stack. And if I want to push number 3 will be pushed in my stack, and number 3 will be the top of the stack. So the other operation we can do on the stack data structure is called pop operation, or removing the data from the stack. This pop operation removes only the topmost element in a stack data structure. If I apply pop operation in this stack, so it's going to remove number 3 first. Then if I again apply the pop operation on my stack, it's going to remove the topmost element from the stack until the stack gets empty. Say I want to again apply push, and I want to insert number 4 this time, so 4 will be the top of the element. Say I want to insert number 6 again, so 6 will be the top of the stack. Another operation we can perform on a stack data structure is called the peak operation, or the top operation, or sometimes it's called top. This operation is going to give us the topmost element on a stack data structure without removing that element. So we can take a look at the top of the stack using the peak operation. Then we can have IsEmpty operation, which is a Boolean operation that returns true or false. If the stack is empty, it's going to return true. If the stack is not empty, it's going to return false. Same case, we have IsFull operation. If the stack is full, so we can apply a IsFull operation. So there are mainly 2 ways we can implement a stack data structure. We can implement it using an array or a linked list data structure. If we implement a stack using array, we learned that arrays are static data structure. They are fixed size, and we need to define the size of an array at the compile time. That's why we need a IsFull operation in the case of a stack array implementation of a stack. If the stack is full, so this function is going to return true, otherwise it is going to return false. So you might wonder where the stack is used. Well, they are used everywhere, from your browser's back button, which remembers the last page you visited, to compilers, operation, and function calls in programming languages, and even in algorithms like depth first search and etc. It can also be used in undo mechanism. Many programs use a stack to save the current state of an activity, or to save the complex state of an action that can be undone step by step. It can be used in memory management, backtracking, balancing of symbols. Stacks can be used to check the proper opening and closing of brackets and parentheses in algebraic expression or a code file. As I said, it also used in page visit history in web browsers. It can also be used in expression evaluation and syntax parsing, function calls, etc. So in this video, we're going to take a look how to implement a stack data structure using array, and in the next video, we're going to implement our own stack data structure using linked list data structure. To implement a stack using array, what I'm going to do first, I will create an array of a specific size. Say I have this array having index 0, 1, 2, 3, 4, 5, 6. So I can store up to 7 elements or items in my stack. Imagine this array is inside a box where all the 3 sides of this box is closed. We can only add elements from one end of the array or this box, and remove or access element from the same end of the box. So imagine that. So what I'm going to do is, first I will maintain a pointer which points to the topmost element of the stack. Let's call that pointer as top. Initially, this top pointer is going to point to -1. When the stack is empty and we don't have any element in our stack collection, top will point to -1. So the first operation we could perform on a stack data structure was push. So we are going to define a function called push. This function is going to take an integer item. Say we want to store integers. Inside this push function, what we are going to do first, we are going to increment the top pointer. Initially, top is equal to -1, which is an invalid index value, means that a stack is empty. Inside the top push function, what we are going to do first, we will increment the top pointer. We will say top plus plus. So top becomes -1 plus 1 is going to be 0. So top is going to point to index value 0. Then we are going to insert the item at this index, which which top points to. We will say array, say this array name is ARR. We will say ARR of top equal to item. Say I want to insert number 1, 3 and 4 in my stack, so I will call the push function, and first I will pass 1 here as an item, so top becomes 0, and array of top equal to item. Item is 1, so 1 will be inserted. If I again want to insert number 3, I will again call the push function and pass number 3 here as an item. And inside this function I will first increment the top pointer, so top plus plus, top is 0, top becomes 1, top is going to point to index 1. Then I will say array of top equal to item, array of top which is array of 1 equal to 3. And if I want to insert number 4, I'm again gonna call this push function, pass 4 here, top plus plus, top becomes 2, it's going to point to index 2. Then I will say array of top which is array of 2 equal to item, 4 will be inserted. Before that, here we will check if, since we implement our stack using arrays have fixed size, first we are going to check if it is full, we are going to return, we will not do anything. So when we know our array is full, when top is equal to size, when top is equal to size minus 1, our size is 7 here, the array size is 7. When top points here, 7 minus 1, 6. When top is at index 6, we know our stack is full and we cannot insert values. Same case, if top points at minus 1 here, initially means the stack is empty, we cannot pop or remove any item from our stack. So the next operation we could perform on a stack is pop operation, which removes the topmost element from our stack. Say I have a stack of 1, 3 and 4. I can only access number 4 first, then I can, after removing number 4, then I will be able to access number 3. After removing number 3, then I will be able to access number 1. So let's define a pop function in our stack implementation. Pop doesn't take an argument, it's going to only remove the topmost element in our stack data structure. First we will check if it is empty. If a stack is empty, we will return we cannot remove or pop any item from our stack. Otherwise, if it is not empty, what we are going to do, we will just simply decrement the top pointer, making the top pointer point to the second last element by just saying top minus minus, top minus minus. If I call the pop function, it's going to first check if the stack is empty. No, the stack is not empty, so it's going to decrement the top pointer. Top is going to come here, top minus minus. So this element is not point by pointer. We can only access the element using the top pointer, which points to the topmost element in our stack. We can either delete this item or set it to 0, or otherwise we can leave it like that, since we can only access number 3 using the top pointer. So right now our top is number 3. If I again call number pop, so the pop is going to check if a stack is empty. No, stack is not empty. It's going to do top minus minus. Top is going to point to index 0. Top comes here. So right now number 1 is the top of our stack. If I again call the pop function, stack is not empty, it's going to do top minus minus. Top becomes minus 1 and the stack is empty. So this way we can implement the pop and push function. Then we have the peek function. The peek function is always going to give us the topmost element in our stack. Say the stack is empty right now. If I want to insert number 1, 3, 4 again, so I can call push function 3 times. My top is going to point here after I inserted 4. So the peek function is going to return the topmost element in our stack data structure without removing it. So it's also not going to take an argument, and it will return an integer, which is the topmost element. First we will check if a stack is empty. We cannot return anything, otherwise we are going to return array of top, the topmost element. Okay, this is the peek function. Sometimes it is also called the top function. Some programmers used to call it top or peek, so most of the people call it peek, so I'm going to call it peek too. Say I wanted to pop or remove number 4, so I will call the pop function. Pop is going to decrement the top pointer, top minus minus, top becomes here. Say again I want to insert number 10, I will call the push function. If is full, no, stack is not full, it's going to increment the top pointer, so the top is going to come here, point at index 2. When I say top, array of top equal to item, so it's going to replace number 4 with number 10. When I call the peak function, again it's going to return array of top, which is array of 2, it's going to return number 10. So in this video we're going to use C# to implement our own stack data structure using array. Once you learn the concept, you can use your own favorite programming language to implement the stack data structure. So let's get started and implement a stack data structure using array in C#. So what I'm gonna do, I will create a class, let's call it my stack. I'm going to right click here and add new item. I'm gonna add a class, let's call it my stack.cs. So inside this stack, as I mentioned, we are going to use the array data structure. For that we will need a size. So what I'm gonna do, I will take a size from the user, the maximum number of elements to store in the stack. So let's call it private and let's call it size or maximum size. Let's call it max size. Then we will have a top pointer, let's call it private and top. Then we are going to use an array to store the items in our stack. I'm going to use integer array, let's call it array. So inside the constructor, I'm going to take the size from the user, public my stack, and let's call it max or size. So this dot size or max size equal to size. Also we are going to initialize our array using the size passed by the user. Then initially we are going to set this dot top equal to -1, indicating the stack is empty. Then we are going to implement the push function. Before that, let us define the IsEmpty and IsFull function. So this is going to be public, a boolean function is empty. When the stack is empty, the stack will be empty when the top pointer points to -1. So we will return top equal to -1. If top is equal to -1, it's going to return true, otherwise it will return false. So return. Then also we are going to implement the IsFull function. Public boolean is full. When the stack is going to be full, whenever the top points at the end of the array, or if a stack points to the size -1, which is the last index of the array, means a stack is full, we cannot insert more items. So we are going to return top equal to max size -1. So if this condition is true, it's going to return true, otherwise it's going to return false. So to implement the push function, public, let's call it void push. This is going to take a value from the user and push it to the stack. Before pushing, we'll check if the stack is full. We will prompt the user, the stack is full, we cannot enter. If is full, we just want to return from the user overflow stack is full, and we just want to return. Otherwise, what we are going to do, first we are going to increment our top pointer, top ++, and then we are going to insert the value at the top of the stack. Then we had the pop function, which returns the topmost value from the stack, and it decrements the size of the stack by 1. So let's call it public int. So let's return the value removed from the stack. This is going to return an integer value. First we are going to check if the stack is empty. If is empty, if top is equal to -1, so we are going to return -1 or a code, and also we will prompt the user underflow stack is empty. We cannot do anything. Otherwise, what we are going to do, we just want to decrement the top pointer, and top is going to point to the second last item or index in our stack. Once the top becomes here, we are going to lose the reference to this previous top. Before decrementing the top, what we are going to do, we are going to store this value, the current top, to return it, and then we are going to decrement the top pointer. So before top minus minus, what I'm going to do, I will say int current top equal to array of top. Then I will do top minus minus. At the end, we are going to return the current top. Then we have peak function, public. It's also going to return the topmost element in array without removing that. So let's call it peak or top. We will first check if the stack is empty, we cannot take a look at the topmost element of the stack. So we check if is empty. We are going to prompt the user stack is empty. So if the stack is empty, we are going to return -1 or something. Then otherwise, if the stack is not empty, we are going to return the topmost element in our stack. Return array of top. That's it, I think. So let's define our stack here. So I'm gonna define my own stack. My stack, let's call it s equal to new my stack. So I'm gonna give the size as 5. So I want to store 5 numbers in my stack. So if I call a stack s.push function, say I want to push number 1. So before that, so let's print the peak. So peak, I'm gonna call the peak function here is.peak. It should print number 1. A peak equal to number 1. So we are going to add a function in our stack to print all the elements of the stack. So what I'm going to do is I will start, if the stack is not empty, I will start traversing from 0 going all the way to top and print each element. So let's add a function in our stack implementation. I'm going to call it print function. Here public void print. So if a stack is empty, if is empty, we cannot print anything, and we just want to prompt the user stack is empty and return. Otherwise, we are going to use a for loop for int I equal to 0, I less than or equal to top, goes all the way to the top of the stack I++. We are just going to print array of I. So I'm gonna use print line. Okay, so if I call the s.print here, so before that, let us push another value here. I'm gonna push number 4. Let's call push number 40. So my stack has number 1, 4, 40, and the peak is 4. The topmost element is 40, not 4, sorry. We have number 40 at the top, then we have number 4 and number 3. So let's pop a value s.pop. So number 40 should be deleted from our stack, and the top or the peak should be number 4. Yeah, we have 4 and 1, peak is 4. Let's call pop again 2 times, so stack should be empty. Stack is empty and peak is -1. So if I push s.push, say I want to push number 100, 100 should be the new top in our stack. Yep, we have only 1 item and peak is number 100. So this way we can implement a stack using array data structure. Thank you guys for watching. Please don't forget to subscribe and see you in the next video. Bye bye.